Okay, we're going to try it like this. Okay, so here's the problem we're working on. So what you have is you have your point A and your point B with the little person off the diving board. You have your distance, and what the problem is looking for is the force acting on A and the force acting on B. So what you're given, of course, is the mass of the diving board and the mass of the little person. So the first thing you're going to do with this is you're going to define your forces. So you have a normal force working up at point B and a normal force working up at point A. And then you have two more forces. You'll have your force coming down at the very end, and that will be force of the diver. And then you're going to have another force, we can just say right there, going down, and that is of the diving board. Force of diving board. Okay. So from there, since we have all of our forces defined, you are going to essentially solve for one of these, and then from that you can solve for the other one. And to go about doing that, you will take the moment of the whole system. So we'll do that right here. And we'll take the moment as counterclockwise being positive. So if the force acting down, if it makes it move clockwise at the point you're finding it from, then it will be negative. And then vice versa. If it works up and makes it move the opposite direction, then it will be positive. So we'll go ahead and find the moment at point A, and that will allow us to find it at point B. So the moment at point A, you always equal that to 0. And then going down, to find the moment, all you do is you will multiply. If you're finding it at point A, then you disregard the force right here, because that's what you're solving for. So you'll find the moment about point B and about the force of the diving board at that point, and then of the diver. So essentially what you're going to do is you're really just going to take the force multiplied by the distance at which the force occurs. So we can go ahead and do that. So at force of the normal force of at point B, it will be F in B multiplied by the distance at which it occurs, which is 1.1 from A. So we can go ahead and write 1.1, and that force will be negative, because if we're taking it at point A, if that's pushing up, then it'll be positive because it's moving in the counterclockwise direction. So that would be positive. Let's see. Don't mess up on me. Okay. And then if we did the rest of the problem, essentially doing the same thing, we will take the force of the diving board, which is just the weight times gravity, which is 9.81. Forgot to write that. Okay, so we'll take the weight times gravity multiplied by the distance at which this occurs. So the force of the diving board is half of the total length. So since the total length of the diving board is 4.7 meters, the force acting on it, which is at the center, is going to be at 2.35 meters, which is where that's at. So we write 2.35. So knowing that the distance from here to A is 2.35, then we multiply the distance times the force acting on it. So we can say, and that will be negative because it's working in the clockwise direction. So you see what I did? I just multiplied the weight times gravity times the distance at which it occurs. And then lastly, for the last force, we will do the force of the diver. So you'll just take that, which is his weight is 70, multiply that by 9.81, and then multiply that by the total length because he's at the very end. And that will also be negative. We ran out of room. .7 meters total length. Okay, so once you have all that, that's all the forces acting on the system. Once you have that, you will just set that equal to 0. So if I rewrite it a little bit better, it will be go ahead and multiply this out. Let's see. So 26 times 9.81 comes out to be 255.06. So we can just keep the normal force of point B times the distance at which it occurs, 1.1. And then we can write minus 255.06 still multiplied by the distance. And then we'll minus that. And we'll calculate the last force, the total force. So 70 times 9.81 is 686.7. Still multiplied by the total length, 4.7 meters. And that's all equal to 0. Okay. So from there, you will just take all the knowns over to the other side, and you will use algebra to divide by 1.1, and you will be able to calculate your value for your normal force at point B. So doing that, let's see, 255.06 times 2.35 equals to 599.4. Okay. So multiplying the last part. $686.7 times 4.7 Okay, so that comes out to be 3,000 227.5. Okay, so both of those, since the negative sign comes down with it, those are both negative. So if you add those, or put those together and put it to the other side, and set Fn equal to that, your Fnb will be equal to 599.4 plus 3227. So it will be, so your final equation, I guess, would be your added values, which is 3,826.9 divided by your 1.1 when you bring it to the other side, and that will equal your your normal force at point B, the value of that, and that is 3,479 newtons. Okay, so if we go back to the problem way up here, that is your force acting at B. So we can just write 3,479 newtons. Okay, so from there, since we have everything, we have the force of the diver, the force of the diving board, and then your normal force at B. All we need to do is find the normal force at A. So from there, you do the summation of forces in the x direction. You set that equal to 0. So from there, you will just say, since Fn's moving up in the positive and those are moving in the negatives, you would just say Fna plus Fnb minus Fdb of the diving board minus the force of the diver. You set that equal to 0. So if you substitute all your values you have, your normal force in the B is 3,479 minus the force of the diving board, which is just 26 times gravity. Which is 255.06, and then minus the diver, which is your 70 times 9.81. Minus 686.7 equals to 0. And then you will also include your normal force at point A. So from there, it's pretty simple. You just take all your values to the other side, and that will equal your normal force at A. So in doing that, I definitely missed a number, 686.7. So in doing that, we will have Okay, so taking all that over to the other side, it would equal negative 2,537, and that is your point at